Okay, we're going to talk about some dilations. On this video, I want to talk specifically dilations. Remember, are making things bigger or making things smaller. So in this video, we want to talk about dilations as a reduction, which means making it smaller. Okay, there's another video you can watch about making things bigger, which is our enlargements, but not in this video. So if I want to make things smaller, I want to reduce them in size. So we start with our big square that I have here. And just like with all dilations, I'm going to use a scale factor. Now with reductions, our scale factor is going to be less than 1. Remember, if I multiply something by 1, it stays the same size. Bigger than 1, it gets bigger. And so if I go smaller than 1, it's actually going to reduce in size, and it's going to get smaller. So I'm going to use a scale factor of 1/2 or 0.5. Same thing. So if you see scale factors that are going to be fractions or decimals that are smaller than 1, a good key that it's going to be reducing in size. When I perform this reduction, I want to look at multiplying all my numbers for the point. So starting at point A, I want to multiply both the x and the y by my scale factor. So if I take half of 4, that's going to give me a 2, and then half of 4 again, that's going to give me another 2. So that brings point A prime down to 2, 2. And here's my new A. So you can already see that that's kind of moved in, like it's going to get smaller. If I do it for B as well, let's say by 0.5, if you want to try out 4 times 0.5, you'll get 2. If you do -4 times 0.5, you'll also get -2, right? That brings in point B prime to right here. C, if I go -4 times 1/2 or -4 times 1/2, both times I'm going to get -2. So that brings me to -2, -2, and that's C prime. And then again with D, I'm multiplying -4 times 1/2, and then 4 times 1/2, right? Both times, and that gives me -2 and 2. So what I did is I multiplied each value, each x and y value by the scale factor, and that's how I reduced it. I took the 4's in my x and the 4 in my y, I multiplied them by my scale factor right here, and that gave me my new point. And if you look, that creates another little square down here that is actually smaller than my big one. So it really did reduce, but it kept the same size, kept the same shape, right? Or not same size, excuse me, kept the same shape basically, but it got smaller. Now, one other thing to take a look at is my side lengths. Let's look at our original side length. I started out as 1, 2, 3, 4, 5, 6, 7, 8. Started out as 8 long, and remember this is a square, so all my sides were 8 long. Now if I look at my new reduced square, I have 1, 2, 3, 4. So you notice my side length also cut in half, because 8 times 1/2 is also 4. So our reductions not only affect the points, but they affect the side lengths. Okay, so it happens all kind of the same way as far as our points and our sides. So if I reduce it, I do my scale factor times all my points to get my new points, and I should also notice that my side lengths also reduce by that same scale factor, and that's our reductions.